All right, let's journey back in time to a really critical moment in the history of databases. Picture this. It's the late 2010s. PostgreSQL is already a massive favorite. You know, a real darling in the developer community. But it was starting to face this brand new, massive challenge. A challenge born from the absolutely incredible scale of modern data.
And that brings us to the core question of the entire era. This wasn't some academic thought experiment. This was the reality people were dealing with every single day. The amount of data was just exploding. And the problem wasn't just about finding a place to store it all, it was about speed. How in the world do you keep up?
Well, the answer, it turns out, came from two really landmark releases. And these are the heroes of our story today. PostgreSQL versions 12 and 13. Now, these versions didn't just tack on a few new features. No, they went deep. They doubled down on the very heart of what makes a database truly great: raw performance, smarter indexing, and just incredibly intelligent query planning.
So how would they pull it off? Well, the first line of attack in this battle for speed was something fundamental, something happening deep down in the engine. It was nothing short of an indexing revolution. Version 12 really kicked things off with some seriously powerful upgrades. And what's so cool here is how all these pieces fit together. You've got covering indexes to make reads way faster. You have quicker updates to the B tree, which is like the database's core filing system. And then you have smarter ways to handle gigantic tables by joining them partition by partition. It was a full-on, multi-pronged attack on inefficiency. And this right here shows the pure magic of that first point, covering indexes. Just think about it like this. A normal index is like the index in the back of a book. It tells you the page number, but you still gotta flip to the page to get the info. A covering index, that's like having the exact answer you need printed right there in the index itself. It just completely eliminates that second step, making tons of queries dramatically faster. And version 13 didn't just rest on its laurels. It kept refining these ideas. For example, incremental sorting meant the database stopped wasting time resorting data it already knew was in order. Parallelized vacuuming was huge. It used multiple computer cores to speed up essential cleanup tasks. And deduplication, that just made the indexes even smaller and more efficient by getting rid of redundant data. Just smart stuff. But here's the thing. Being fast isn't just about how you store the data. It's also about how the database thinks. And that brings us to the second major leap forward. This was all about making the queries themselves smarter and faster by upgrading the very brain of the database, the query planner. Now, this wasn't about one single new command you could run. This was about teaching the database to be a better strategist. It got way better at figuring out the best way to join complex tables. It started collecting more accurate intel about your data. And, this is crucial, it learned to stick with a good plan once it found one. That meant performance became so much more predictable. And what's so important to remember is that all this super technical, under-the-hood work, it all boiled down to one really simple human-centric outcome. For the actual people using the apps powered by Postgres, it just meant things worked better. No more weird, random slowdowns, just solid, dependable speed. Okay, so we've seen all the technical details, but let's zoom out for a second. Why did these specific improvements matter so much in the grand scheme of things? What was the real-world impact? Well, for one, it meant PostgreSQL could suddenly handle these really complex analytical queries, what we call OLAP workloads, with way more grace. It could also stand up to the pressure of thousands of people using an application at the same time without buckling. And maybe most importantly, it made it the perfect choice for the new world of the cloud, where applications need to grow and scale on a moment's notice. And all of this brings us to what I think is the real theme of this whole era, the true legacy of versions 12 and 13. I like to call it the legacy of invisible wins. This quote just nails it, doesn't it? The biggest improvements weren't some flashy new thing you had to learn. The real win was that the entire system just felt better, more solid, more responsive, and a whole lot more reliable. It was this beautiful chain reaction of improvements. The first victory, as we saw, was smaller, tighter indexes that save space and give you a huge boost in speed. And those smaller indexes, they gave the database's brain, the query planner, better intel to work with, which led to our second win, smarter query plans that could find the most efficient path through all that data. And of course, the end result of all that smart planning was the third and most important win of all: faster responses.
the kind of speed that gives the end user a seamless, frustration-free experience. It's a simple chain of events, but an incredibly powerful one.
And that is the ultimate takeaway. Because with these releases, PostgreSQL wasn't just getting faster. It was proving that performance isn't just a number on a benchmark. It's about trust. It's about building a foundation so rock solid that companies, from tiny startups to massive enterprises, feel confident enough to bet their entire business on it.
Of course, the story doesn't end here. Not even close. This incredible foundation is what allowed the next generation, versions 14 and 15, to start tackling new frontiers. Things like advanced monitoring, better data compression, and making life even easier for developers. But that, well, that's a story for our next Chronicle.